Today we are going to work on geometric mean, okay, the geometric mean. And it's just between two positive numbers, okay? So what happens to the geometric mean? You'll see how it's applied later. It all comes from similar triangles, but you'll have a square term here. You'll have something multiplied by itself. So for 3 and 45, it doesn't matter where the 3 and 45 go. It does not matter, because no matter what, you're going to be multiplying them by each other. Whether you put the 45 here and the 3 here, it's still going to be the same. So I get 3 times 45 is x squared. Okay, I'm going to square root both sides. And I just left that as 45 because I'm going to look at it like this. 9 times 5. That is my perfect square. So I have a 3. 3 and 5. 3 radical 15 is x. I'm not going to ask you any questions like what's the geometric mean of this. It's going to be applications. It's going to be applications. So let's first look at theorem 7.3. It says if you draw an altitude from the right angle, so we have a right triangle ABC. We draw an altitude from the right angle, okay? It is going to form two other triangles. All three of said triangles are going to be similar. All three of these triangles will be similar. The right angles will correspond. That's the easiest one to see. B, D, D. As you see, we got B, D, D. Okay? Depending on the triangle you're referring to, will show the other one. So A and A here are the same A. Okay? This BDC is going to get rotated, right? Rotated around. It's actually a rotation and a reflection to get this B over to this A, right? So that's where we have A, B, A, B. And then the C here is the same as the C here. And then this B up in this one turns down there. Okay, so all three of these are similar. You can use that, right, and try to go through it each time and match them up. It's true, but we're going to have these other theorems that are going to help us. So yes, once I have this altitude, I can use the fact that all three of these are similar to find missing pieces. But what we have are these corollaries to this, which has to do with the geometric mean. Okay, first thing, we have an altitude, right? This is our altitude. 4 is our altitude, okay? The altitude, okay, is the geometric mean of the two segments created by the altitude, right? So look, see how this altitude gives me 2 segments? So the altitude creates a ratio between those 2 segments. The geometric mean of the length of the segments. So how I always look at it is I say it's going to be the altitude and the altitude. The altitude and the altitude is going to repeat. And then you have, however you want to do it. You can call it segment 1, segment 2, piece 1, piece 2, right? Part of the hypotenuse, whatever you want to do, right? So it could be, let's say, part 1, part 2. Right? That's really what it does. It breaks the hypotenuse into 2 parts. Just know it's always going to be altitude times altitude. It doesn't matter which part you put where, because it's going to be multiplied by each other. So let's look here. We want to find GH. So I have the altitude. I don't know GH, but I have the other part, which I don't know, the letter's missing. Let's just call it J. It doesn't matter. Is 9. And this region will be geo mean altitude. You're going to see, because next we're going to have something different. So we just solve this like normal. As always, we reduce when possible. 3GH is 12, GH is 4. Okay. It asks you to find the remaining sides. Well, what do I have here? I just have a right triangle. So 6 squared plus 9 squared equals EJ squared. And then you do the same thing here. 4 squared plus 6 squared is HE squared. So I want you to finish on own. Just practicing your Pythagorean theorem, that's it. The main thing here is know that if I have the altitude, it's the geometric mean of the two parts of the hypotenuse. Okay. Next one, corollary 2, which we're going to call this geomean leg, right? Because in this case, we have the leg, okay? So we still have our altitude from the right angle. We still have our altitude from the right angle. Now we have the value of the leg. So the leg, if I have the leg, right, it's equal to the geometric mean of the hypotenuse and the adjacent piece. See how 1 is adjacent to the leg. So it's always going to be the leg. The leg is the geometric mean of the adjacent piece to the hypotenuse. I don't really need to rewrite that for you, but this is what it looks like. I have the leg, hypotenuse, and adjacent part. Okay? And you call it geomean leg, because we're using the leg. The geomean altitude, we use the altitude. So here, it's important to know the difference. Let's solve for x. X is the leg, right? X is the leg. So it is the geometric mean of the hypotenuse, which is 12, to the adjacent piece, 3. So I have x squared is 36, x is 6. Now, yes, I understand you could do, hold on, this is geomean leg. I understand that you could do the Pythagorean theorem here, but I want you to do the geomean again for y. It's going to be the geomean leg. Y is my leg. I have the adjacent piece 9 and 12 is the hypotenuse. Y squared, 108. I'm going to square root both sides. 36 and 3. So y is 6 radical 3. Those are my two answers. Okay? So you have to know the difference. Is it geomean leg? That means I have the leg and parts of the hypotenuse. Or is it geomean altitude? Right? I can actually find the altitude here. Here's the altitude. It would be the altitude is the altitude, and it's going to be 9 to 3. And this is geomean altitude. 27 is the altitude squared. Square root both sides. 3 radical 3 is the altitude. Okay? Make sure whatever you're doing, you're labeling it as a geomean altitude or the geomean leg. Okay. Here we have some square root stuff, right? Some radicals in it. It doesn't matter the order in which we do it. Let's do y first. Okay? So the y is going to be geomean altitude. Y and y. Radical 8, radical 2. Y squared is equal to the square root of 16. So y squared is equal to 4. Y is equal to 2. know that's a terrible drawing picture. That doesn't really look like a right angle. But we found our y, okay? Let's look at w. Geo mean leg. Well, the adjacent piece is radical 8. Here, the hypotenuse is radical 8 plus radical 2. It's radical 8 plus radical 2, because you can't, that's not radical 10. You can't just combine it like that, okay? Hopefully, or maybe, and if not, you'll see it now. This is 2 radical 2, okay? So now the whole hypotenuse, 2 radical 2 plus radical 2, right, is 3 radical 2. We could do it this way, but I think it'd be much, much easier if we did 3 radical 2. Okay, so now I have 3 radical 16 is w squared. Radical 16 is 4, so that's 12 is w squared. W is 2 radical 3, okay? So we're getting back to our radicals again. We need to really be able to manipulate radicals. We need to be able to manipulate radicals. Geomean leg again for x. The hypotenuse is still 3 radical 2, except now I have a radical 2 here. X squared equals 3 radical 4. 6 is x squared. Square root both sides. X is radical 6. Okay? Those are our 3 values using the various ways. Now you have some students complete. Work on those. We will go over them in class.